Good morning, this is your Stat Sensei, Mr. Spensei, and this is a two sample proportion, and we're going to actually run a confidence interval for the difference in proportions. Um, so, a large national bank is considering expanding its investment mobile banking services to enhance accessibility and customer experience. A digital banking As digital banking becomes increasingly vital, understanding usage patterns across income levels is essential for making strategic investments that benefits all customers. Lower income customers may rely on mobile banking due to limited access to physical branches or time constraints, while higher income customers may use it for convenience. Identify differences and adapt and adoption rates can help the bank allocate resources effectively, improve digital service, and bridge potential gaps in financial access. That's a lot. The bank serves approximately 350,000 customers below 50,000 per year. All right. So right here we have one population that is making less than 50K or saving less than K, and 420,000 earning more than 50,000. So this is a second population. So this is pop 2, and it's greater than 50K. To analyze usage differences, the bank randomly sampled 180 customers from the below 50,000. So we have an N1 equals 180 and 220 from the above 50. So N2 is going to be, N2 is 220. Each customer was asked whether they use mobile banking or for financial transactions. The results showed that 130 of the 105, so X1 is 135. Customers earning below 50,000 and 140 of the 120. So X2 equals 140. All right, so that was our scenario. So let's look at our question. Construct a 93% confidence interval to estimate the difference in the proportion of all customers in each group who use mobile banking. So, real quickly, looking back at what we said, we had two groups, the group earning less than 50,000 and the group earning more than 50,000. We said there was a half sample size of 180 versus a sample size of 220. And we had 135 said that they would, and 140 over here said that they would. So that gives us that. And remember, we have p hat 1 and p hat 2. And remember that p hats are just basically x divided by n. So in this case, that's what we have, 135 divided by 180. And when we check that out real quickly, 135 divided by 180, we get 0.75. And then we have 140 divided by 220, and we get 6363. Okay, so um, we can go ahead and graph this thing, and the graph is going to be, well, we wanted a 93% interval, and it's going to be centered on p hat 1 minus p hat 2. Well, the way we did that is we really did just subtract them, 0.75 minus 0.6363. And that's 1137. So the difference between the proportions, and that's why it says p hat 1 minus p hat 2 right there. I don't know how well that shows up, so I'll rewrite it a little bit bigger, but p hat 1 minus p hat 2. All right? Okay, so our formula is the sample proportion 1 minus sample proportion 2. Well, we already calculated that. And then we have sample proportion 1 again, and here it is again, and that sample proportion 2, and sample proportion 2, and sample size 1, and sample size 2. So we have everything except for Z star. So we're going to have to go back and calculate Z star, and the way to calculate Z star is second vars inverse norm in this case, parenthesis 1 minus 0.93, close the parenthesis and divide by 2. Because it's a z, it's going to be 0 and 1, mean of 0, standard deviation of 1. Go ahead and keep it left, and we're going to go ahead and change that to a positive. So this right here is my mean. This right here is my standard deviation. That did not look like a standard deviation symbol. I'll see if I can draw that a little bit better. There we go. So a little better, not much. And 0.18119. So now we have everything we need to plug in. We're plugging in p hat 1, plugging in p hat 2. Right here, we have our z star. And p hat 1, 1 minus p hat 1, or sample proportion 1, 1 minus sample proportion 1 over our sample size of 180. Sample proportion 2 times 1 minus sample proportion 2 over our sample size of 220. We're running a 2-proportion z interval. So let's go ahead and run that. So we're going to go stat test. We're going to drop way down to letter B, 2-proportion z interval. We have 135, 180, 140 out of a sample of 220. And we said up here we wanted a 93%. So 93 divided by 100. And we end up getting 0.03073 and 0.19654. All right, so that's the 2-proportion z. Now earlier we calculated that 1137 by going p hat 1 minus p hat 2, 0.75 minus 0.6363. But I want to show you one other thing. This will help some AP stat kids out and some other people understand what's actually happened. Let's take these two together and add them. 0.03073 plus 0.19654. And we're going to take that and divide by 2. And guess what? There it is. That's just the rounding differences. All right. So the center of the confidence interval is what we just marked here. And we calculated it by going p hat 1 minus p hat 2. But we could have taken the average of the lower and the upper as well to get there. All right. So we need to define our parameters. Well, we have 2 proportions. So we're going to have 2 parameters. So 2 populations. We have the population of mobile bankers making less than 50,000, and the proportion of mobile bankers using it making greater than 50,000. Notice both of them have proportions, and we separated the groups based on whether or not they were less than 50 or more than 50. All right, that's going to be really important when we actually get to our conclusion. The next thing we need to do is we need to look at our conditions. The first condition, well, we need to have 2 random samples. When I look at this, we had a random sample of 180 and a random sample of 220. So we have 2 independent random samples. So random sample of 180, yay, that was given to us. We can check that off. Random sample of 220, that was given to us. We can check that off. And they were both independent. All right. So we can go ahead and we're good with that. Now we need to make sure that our samples were not too big. So we need to look at our populations. Well, sample 1 was 180. We wrote it right here. So what's 180 times 10? Well, that's 1,800. But we were told we had 350,000. So 1,800 is definitely less than 350,000. All right, this one wasn't too big. What about this one? Well, 220, we have it right there. 220 times 10 is 2,200. And we've said that our population was 420,000. So guess what? It's not too big either. So now we know that our sample wasn't too big, but was it big enough? All right. Since it's a confidence interval, please pay attention. We're going to use p hat 1 and p hat 2. Hypothesis test, on the other hand, uses p hat c. So we're going to use p hat 1 and p hat 2. So sample size 1, which is 180, times p hat 1. Well, we're going to have to flip all the way back up there, and we see p hat 1 is 0.75 and p hat 2 6363. So we're going to use those. All right. So 180 times 0.75 is 135. That one's big enough. Is the second part big enough? So I have to go 180 parentheses 1 minus 0.75, close those parentheses, and I get 45. It's bigger than 10, so that's good. Over here, we had sample size of 220, and our p hat 2 was 6363, which is right there. So 220 parentheses 0.6363, 139, big enough. And then 220 parentheses 1 minus 0.6363 is 80. It's also big enough. So we know that both are large enough to proceed, which we already did. Okay, we ran our test. We ran and got this as our confidence interval. So we are 93% confident the true population proportion difference between mobile banking users making less than 50,000 and those making more than 50,000 lies within the interval. And this is just a restatement of that. Restatement of the interval we calculated. The 93%, that's what they asked us to do. Now, let's look at this. The true population proportion difference. Got to have this word. Super important to include the difference between mobile banking users less than 50,000 and those making more than 50,000. All right, last thing, the meaning. In repeated sampling, we expect this method to capture the true population difference in proportion. Gotta have the difference in there. Of mobile banking users making less than 50,000 and those making more than 50,000 93% of the time. Less than 50,000, more than 50,000. All right. That's it. That's all we have for this video. Appreciate you watching and look forward to seeing you on the next one. Thank you.